Hey, welcome to HackAtom first Cosmos Hackathon on the Russian language. And we have one more workshop today. There will be Deepanshu who will talk about NFT application, how to build NFT application with an interNFT module. Deepanshu, can you hear me? Let's make a little check.
Yeah, hi Nadia, I can hear you.
Okay, cool. Great. So we will have two channels today, one in Russian and one in English, and I will monitor question at both channels on YouTube and also on one more channel on Telegram chat with our hackers. HackAtom RU, yeah, you see it on the screen. So if you hear this workshop live, you can just ask questions, and I will read them all at the end of this workshop. So, and now I give on the floor to Deepanshu. Please go ahead.
Yes, thanks, Nadia. So, hello, HackAtom Russia. Hello, Cosmos Community Russia. So this is Deepanshu from Persistence, and this is a workshop to discuss an NFT implementation through the interNFT module. So to kick off, here are some of the links that you'd find useful throughout this particular workshop. I think these links will be shared to you through the chat box, the stream chat box. So hope you have gotten access to it. To give you a brief insight into what this workshop is about, I'm going to be discussing the new standard that we are working on in the Cosmos space with the help from ICF. It's called the interNFT app standard. So this particular standard defines a native implementation of NFTs in the Cosmos ecosystem that is not dependent on any formats of smart contracts, etc. It is at the protocol level, it is at the native chain code level, and defines a singular execution mechanism for NFT rights and transactions, which remains same throughout the interchain universe. So if you have minted one NFT through the interNFT standard, then all the transactions and rights that one can exercise on these NFTs at the originating chain could similarly be exercised at any other chain which this particular NFT is transferred through. You can find out more about the standards, all the requests for comments, and the work group meetings through these links on the website internft.org. Although in this workshop we are going to be going through a bunch of steps to be able to demonstrate how to import these modules into your project and start utilizing this at your project level, there will be the last section of this workshop will go into this demo application called hosted at the URL demo.internft.org. So this particular website will help you create your own NFT structure, the authentication authorization rules on top of it, and help you set up your own NFT marketplace with zero code. So yeah, that's a quick brief into what we are going to be doing in this hackathon. So there's a lot of ground to cover, and yep, let's get started. First of all, what is interNFT? What are interchain non-fungible tokens? So currently there are a bunch of standards that we very well know NFTs by. These are the ERC standards on Ethereum, the Solidity smart contract level, the ERC 721, ERC 1155, ERC 994. And all of these smart contract based interfaces are centered towards state management and manipulation at the smart contract level and not at the interchain level. In also on top, like unlike the token wallet implementation, the NFT implementation is not at the native chain level, but rather at the smart contract level. But what about chains like Cosmos, where like the module implementation is at the native chain code level? And what would it mean for the interchain IBC world to implement such a native module, native chain code level module? So the challenges that one would face in implementing such a module will be to define a single standard representation of how of the NFT ownership itself. So like the coins structure that we have in Cosmos, one has to define one singular structure that irrespective of the implementation of NFT can represent the ownership. Uh, then we'd have to settle down on a bunch of metadata types that we would utilize in these NFTs and have a singular representation mutation logic across the chain. We have to define a ID, the decentralized ID resolver for these NFTs, so that irrespective of the chain that they're sitting at, if one has the identifier for the NFT, they are able to resolve it in the interchain universe. Um, but on top, there are complications on how to link the identity of other accounts and other objects to the metadata of this NFT, how to link resources to these NFTs that are on-chain versus that are off-chain resolvable. So these were the challenges that one might face while implementing this particular like implementation of interchain NFTs. And for the past 6 months, we have been working on defining the solutions and the best ways forward to implement these. And in this workshop, we're gonna go through the current sample implementation and see how to import these modules and start taking them around to build their own implementation. So,
Deepanshu, can I ask you to speak a little bit louder because we can't hear you well? Oh. Or maybe, yeah, super cool. Thanks. Sorry for interrupting.
Is it better now? Is it any better?
Yes, now it's better.
Oh, okay, good. So yeah, quickly going back to the base characteristics of this NFTs and the metadata associated, they should be uniquely identifiable. As in, if I give one identifier, they should not refer to multiple NFTs throughout the chain. It should be only one NFT throughout the interchain universe. They should be ownable and resolvable. As in, like if I have NFT, it should be owned by one person and should be resolvable to one chain, and a set of documents should be the result of this resolution of the NFT. Should be decentralized. There should not be any central authority or name service that would issue the identifiers for this NFTs. They should be persistent, as in even if they are deactivated, the representation and should keep on existing. And even if the chain that is hosting this NFT, issuing this NFT goes down, the NFT representation should still stay active. The content should be cryptographically verifiable, as in the verification relationship, verifiable claims, etc. And the integrity of the properties of the NFT should be cryptographically verifiable, and they should be stateful, as in whenever there is a mutation that happens on these NFTs, the previous state is maintained, and the state transition happens through a bunch of predefined state transition logics and do not happen all of a sudden and all of random. Going through the quick salient features of this interNFT work, interNFT standard. First of all, the ownership and the metadata are separated out, as in whenever one has transferred the NFT, they do not have to fully take the NFT object and put it in one's wallet. There is a ownership token that sits in the wallet, while the metadata sits as a separate object and is never transferred. The bytes are never mutated whenever there is an ownership change. The ID generation is such a format that it ensures that there will be never clashes, uh, and not only in the host chain but also in the interchain universe in the namespace. Uh, there would be just one wallet implementation required that can hold all kinds of NFT, unlike the ERC 721 wallets that hold only one kind of NFT at a time. This particular standard could allows one wallet to hold different classifications of NFTs and also NFTs from different chain. Uh, this implementation also exposes our inter-NFT interface and NFT interface. Although there is a reference implementation for it right now, it's totally possible for a person to uh, uh, in, have their own base implementation of these interfaces. Fifth, reduce flows on interchain protocol. Since the mutation and logic and metadata are separated from the ownership logic, even if one were to transfer the ownership token to the other chain, there would not be a constant communication required between the two chains to manage the ownership data. The ownership is singular and follows the same rule irrespective of which chain it is on. So there's not a lot of to and fro that happens, reducing a lot of load on the interchain protocol. Commoditization, as in each of these NFTs carry a classification trait. So if one wanted to refer to, let's say, how many cars do I have in my wallet, then one can do so in single query. And if one wanted to say, I want to send 7 cars from my wallet to yours, then they can commoditize these car NFTs as cars and like send them in a single go. Trusted minting, mutation, and burn execution logic. So, of course, as long as the modules are utilized without a modification across chain, one can ensure that there is certain level of privacy and trust between the execution logic. But to fully ensure of it, uh, the mutation, minting, and burn logic is always localized to the issuing chain. So, for example, if there were an NFT that were a limited edition NFT and one could only mint 100, even if the NFT were to be, the definition were to be transferred to another chain, the other chain won't be able to mint this NFT. Only the issuing chain will be able to mint, and that way it could ensure that there are only 100 of these NFTs, and only the native chain is able to mint more, and no other chain is able to do it. All the chains are able to take care of other transactions like send and receive, etc., but not transactions pertaining to minting, mutation, or burning of these NFTs. And the last one is it's a native implementation. It's not a smart contract based implementation, and which is to be included into the SDK set of modules. And as long as one is utilizing these modules, like these modules ensure interoperability and homogeneous execution across chains.
Deepanshu, we have an issue with your sound. Sorry. Let's check where is your microphone, because we can hear you. We can't hear almost anything. Yeah, this doesn't help actually, because we don't know where is your microphone right now.
Oh, my microphone is right at the top.
Yeah, and you have to make it a little closer to your mouth, because we really can't hear you at all.
Let me take my Zoom setting once.
Yeah.
I'll stop sharing screen for it. Sorry.
Sorry for the interruption, guys. Let's just fix a little problem and make our lives better for the next half an hour.
How's this now?
Wow, yeah, now it's working perfectly.
Okay. I think it was the noise suppression setting on the Zoom that was messing with my volume.
Yeah, probably,
Yeah.
let's maybe come back to one, I don't know, one paragraph or something before. Yeah, somewhere here.
Okay.
Yeah,
Core
thank you. Sorry.
characteristics. All right, got you. Sure. To discuss the core characteristics of these interchain NFTs, they should be uniquely identifiable, as in even as long as there is a set of immutable properties that separates one NFT from the other, the identifier of the NFT should be so and such that if I had one decentralized identifier across the interchain universe, irrespective of how many chains there should only be one NFT that gets resolved from identifier. There should not be any clashes or a double representation of NFTs. So this particular standard ensures that there is never clashes in the namespace. Second, there should be ownable, as in each NFT, there should be a controller property that gives rights to ownership and mutation to the ownership holder of these NFTs. They are resolvable, as there is a DID resolver component that takes in the decentralized identifier for these NFTs, and it sits at the top level decentralized identifier resolver level, which deals with other DID resolution also, and also deals with the resolution of Cosmos namespace NFTs, and is able to resolve irrespective of where the NFT, which chain the NFT is sitting on. It's able to resolve one NFT document for one identifier given. It's decentralized, as in there is no central authority that is issuing the IDs for this NFTs, or there's no namespace where one has to buy the names, etc. for the NFT. The NFT generation and its ID generation is it's totally decentralized. Fifth, it's persistence. That persistent. It implies that even if the chain that is hosting this NFT, that issued this NFT, goes down, it does not imply that the NFT stops existing. So these NFTs, the state of these NFTs are persisted across different chains, so that even if there are a few failures, the NFT does not stop existing. Six, it's cryptographically verifiable. So each of these NFT carries with them a verification method that, irrespective of if it's on chain or off chain, the holder of this NFT can quickly verify who is the owner of this NFT through certain verification method. In this scenario, it's the public signatures from a public key that are included in the verification method of the NFT that one can utilize. And on top, the identifier of the NFT contains a hash of the immutable properties of this NFT. So one can be sure that the content or the immutable properties of the NFTs are not messed with, because if you change it, the identifier changes and the context totally changes as to what we are referring to, what NFT we're referring to. The seventh is the statefulness, as in the state transitions or the state changes of this NFT, for example, of mutation or ownership transfer, follows a deterministic state transition methods and does not happen randomly, as in there is no method that will just allow you to mutate an NFT to something that changes its ID, etc., or change ownership of the NFT to a user from a user which does not own this NFT, so that these NFTs are stateful as well. Yep. So the salient features we have are for this NFT is the ownership representation and the metadata. These two structures are separated out as in the ownership the structure lies in the wallet, while all of the metadata lies as a separate structure in another KB store, so that whenever you're transferring NFT, the metadata does not have to be transferred. Only the ownership token has to be transferred. This leads to point 5. I'll jump to point 5, which says reduce load on interchain protocol. So since these ownership and metadata structures are separated out, even if the ownership representation is transferred to another chain, it does not imply that the whole metadata of this NFT will have to be transferred along with it, which drastically reduces the amount of the size of the transaction and the load on the chain, on the interchain protocol, as well as the ownership logic and the metadata mutation logic are not connected to each other, strictly connected to each other. So even if the NFT ownership exists outside of the issuing chain, the host chain does not have to communicate back to the issuing chain, even if there is a ownership transfer happens in any time period. Uh, there is a singular wallet representation, which implies that unlike ERC 721, where the wallet of the NFT is basically a query that you make to the smart contract to check if a particular address has an NFT or not. So here the wallet it contains the ownership representations from any kind of NFT. It's not just one singular implementations NFT that this wallet carries. It could be any implementation that one wallet could hold the ownership representation of. And secondarily, it could also hold the ownership tokens of uh, NFTs that are that from other chains as well. So it does not have to be your native chains NFTs that get represented in your wallet. You can hold NFTs of any classification and NFTs from any chain into one singular wallet, and without having to scan a number of contracts to see where you own the NFT at, unlike the ERC 721 implementation. There is implementation flexibility, which implies there is that inter NFT interface that is exposed, and anyone can implement this interface. Although the current reference implementation already implements it, if one wanted to modify it a bit, they can do so and have a more flexible implementation of this particular standard definition of NFTs. The sixth point is commoditization, as in each NFT carries a hierarchy of classifications. So, for example, Toyota Prius can be referred to as a car also. It could be referred to as a Toyota also, and it could be referred to as a Toyota Prius with the registration number XYZ. So, what that allows you to do is a send transaction that allows you to transfer 5 cars from your wallet, instead of saying that I want NFT 1, 2, 3, 4, and 5 to be transferred. So that leads to a certain level of commoditization of these NFTs. Trusted minting, mutation, and burn execution. That implies that although these the logic to mint, mutate, and burn can be implemented by any chain, but these rights are reserved. This execution of this transaction is reserved only for the issuing chain, so that even if a new chain which is hosting this NFT on transfer modifies their module logic, they are still not able to mint NFTs in a Byzantine fashion. Only the issuing chain has the rights to mint. So, for example, let's say let's take an example of a limited edition NFT. Now, this NFT, only 100 of them could be minted. Even if a chain wanted to mint more of these NFTs, they could not, because the right to mint this NFT only lies with the issuing chain. although the host chain does have the capabilities to handle the ownership transfer transactions for these NFTs. 8 point is this is a native implementation, unlike the ERC 721 smart contract based implementation. And through implementation of the same modules across chain, it ensures that there is interoperability between these modules, these NFTs across chains. Quickly going through how this is better than ERC, not better, sorry, different to ERC 721 implementation. The NFT address resolution happens through a resolver, a DID resolver, rather than through a query of a smart contract. The NFT wallet is a singular wallet that can hold ownership representation of multiple NFTs rather than it being a query to a smart contract. There is no smart contract overhead since it's a native implementation. The execution times, the environmental impact, etc., of and energy consumption of these NFTs are low because of there being no overhead of the smart contract execution. And fourth is interchangeability. One can take this NFT and like transfer the ownership and rights execution logic over to other chains. Yes. At this point, I think I've got 15 minutes left. Nadia, should I go through the workshop steps, or should I directly jump to the no-code demo? Because code steps are going to take some time to go through, maybe more than 15 minutes.
Yeah, we can just go to the code session. This is okay. So take your time.
All right. Got you. Cool. So yeah, let's get into the hands-on workshop session. So these steps I've already done, so I'm not gonna do them again. But to give you a quick insight, one just has to make directories, close their project, and set up their IDE. One can utilize the Asset Battle project, which is available on persistence.word/Asset Battle to run their NFT project. Or if one wanted to import this particular modules, they just have to add the repository github.com persistence SDK into the go.mod at version 0.1.0. Yep. So after setups, just getting into a quick brief about the modules that will be utilized. So these modules depend on three other modules, which is the bank module for wrapping, unwrapping the tokens, wrapping and unwrapping the coins. The auth module for verifying the transaction signatures, and the params module for managing the parameters of the rest of the modules. The persistent SDK modules that we'll be utilizing is identities. Since the ownership representation of the token has to be same throughout the interchain universe, there is a new construct called the identities that we utilize, so that even if the ownership has to be represented for a same person across a different chain, one can use a singular identifier for the account rather than having to transfer it to a new account on a separate chain. The asset module is what handles the logic for the minting, mutation, and burning of the NFTs. The splits module handle the split ownership representation, or rather to simplify, just the token representation of this NFTs and the ownership logic. The orders module is a decentralized exchange that helps exchange these NFTs for other NFTs, or exchange them for other coins, etc., based on a maker-taker order book, decentralized order book. So yeah, To import the modules, as I mentioned, just add this particular line to your go.mod, and to initialize in your application.go, one has to add to the keys the identities module keys, and similarly the keys for assets, splits, orders, and modules. To initialize a module, every module exposes an initialize method which asks for the other keepers that it's dependent on at the subspace, the param subspace. So this is how one has to initialize a module in the application.go. And to finally, if one wants to enable WASM smart contract interactions with their module, one has to include this modules and their message encoders into the message encoders set, this final the penultimate parameter in the WASM keeper. So like in this scenario, the WASM custom encoders of like assets, classifications, and identities have been included like so in the WASM keeper to enable interaction of the WASM module with your particular modules. But it's not a necessary step. One can skip it also if they do not want to enable the WASM smart contracts. Yeah. So, like one more step for them for your application to be able to register all the endpoints, etc. Like one has to add your modules to the module manager, your application.go's module manager. So one can do it like so, adding it to the Veradic parameters set of new manager method of SDK types module. Finally, one no, not finally. There are a few more steps. Pardon my. Yeah. So then we have to set the Genesis order. So application or module manager that sets Genesis order, one has to include their module name. So in this scenario, it is done like so. So this particular method ensures that the interdependencies or like the setup procedure is done in such a way that the modules that are dependent on other modules do not like get into a conflict or a dependency loop state. Yeah, now we are the final step. If you want to add make a sim app out of your application, then one has to add the simulation manager object also to your application. But this is only for creating your simulation application. It's not for creating your real application. So after you have added these modules, like how would you start interacting with these modules? So if the initialization is correct, when you start your application, either you're gonna like have the node run properly without throwing any errors, or it's gonna if there is any errors in importing the modules and initializing them correctly, so there's gonna be a panic with the message uninitialized usage. So that would imply that you have made some mistake in any of the steps above mentioned. So yeah, one can recheck these steps and see where they went wrong. After the modules have been imported and initialized into your application, there are two methods to interact. The first method is through the CLI itself, and the second is through the REST endpoints. For the CLI, the structure is the same as Cosmos. Your binary name followed by TX or query. Then the module name that you imported, and the transaction or the query name that you want to run. When one tries to run it, what will, if there are a few flags missing, the command line interface is gonna prompt back reporting what the error is and asking for more flags or parameters to be added. The other way to interact is through REST endpoint. The REST endpoint, in the REST endpoint, after your host endpoint for the REST endpoint, to access any of the persistent module, you mention xprt slash your module name slash the transaction or query name. Uh, so next we have the steps to set up your asset battle project. So to like running quickly through it, you just clone the repository. There is a setup script already there. Don't have to do anything else other than run the script. And there is a startup script. Just run this, and you're good to go with running your node. There are no extra steps. And when you're done with everything, just run this shutdown script like so from your asset mantle root project folder, and your application will be shut down. So as easy as that if you want to set up and run asset mantle project itself. So at this point, the workshop will diverge into two different like branches. One of the branches is defining your own NFT structure through through sending transactions directly, or as another option, you can utilize this a bit more user-friendly UI to make your own NFTs. So what I'm going to do is I'm going to quickly run through how to send transactions, set up your NFT structure and through transactions, and then I'm going to replicate these steps at the web app level. So to set up your NFT, first thing that you would require will be to create an identity for yourself and associate a public key with it. This public key will be utilized to authenticate any transaction against your identity. The simplest format of identity that one can create is called the nub identity, and the transaction for it is under TX identities nub. So the only extra parameter that one has to give on top of the default parameters is the nub ID, which is like your username. So as long as this particular string is not taken up by anyone else, you will be able to register this nub ID, which would be like a username that you can link your keys to. The key that you're sending your transaction from will directly get linked to this identity. And if you wanted to link more keys or remove keys, then there are transactions in the TX identities, provision or unprovision. To query your identity, one can go through the query identities, all the default parameters followed by the identity ID, which is so, or if you omit this parameter, you're going to be querying all the identities that exist. To define the NFT structure, one has to use the transaction assets defined on top of the default parameters that one has to give. One has to give the from ID is different from, which is the key name. From ID is your identity identifier, which we generated through the nub ID transaction. Which so in this case, it's a string that looks like this. It's a DID. On top of this, one has to send define what will be the mutable meta traits. So immutable traits are which you cannot change. For an NFT, they are fixed. Mutables are traits are something that can be changed in the future. And meta traits are traits whose metadata is stored on chain, and non-meta traits are something whose some traits whose data is not stored on our chain to preserve privacy. So, for example, if you're creating your driving license, you would not want your address to be published on the chain, so you would make it a non-meta field. So to specify the properties, this is the format. You give the trait a name followed by a colon, followed by the metadata type. It could either be a string, decimal, height, or ID type, followed by a pipe. And after that, one has to specify the default value. So the default value you can leave empty, but if you specify the default value, then all your NFTs will be minted with that value in the NFT's default. So for example, if you're minting a car that has the manufacturer name set as Ford, so you can set the default of the property manufacturer as Ford, and all the NFTs minted through that classification will always have the name Ford. So this is how we define an NFT structure or NFT template. The response for this would be a classification ID. You can utilize this classification ID to mint your own NFT after that. So the transaction for that is assets mint on top of the default parameters and the from identifier. One has to give the to ID, which is the ID that you would want to set this minted asset to, and the classification ID that we just defined in the last step. The parameters would be the same as the ones that you defined in the last step. So in this scenario, we have defined parameters like B, C, D. So I just specify the property value of B, C, D, and that will allow me to mint the NFT. After that, the issuer of the NFT, or the person who the address that defined the NFT, becomes the controller or the maintainer of the NFT, and they can issue transactions like the mutate transaction. The mutate transaction will allow the issuer to change any of the mutable properties of the given NFT. A set transactions works very similar to how the send coin transaction works. So it's under splits space send. On top of the default parameters, you give the from and to ID, the identifier, the DID of your NFT, and the amount that you would want to send. By default, all NFTs carry an amount of the smallest deck, so as to prevent them from being divided further or to be like fractionalized. But the NFT could be refudged, and like more abouts could be minted. So, for example, an NFT could have about set as one, and one could share this one about into pieces as small as 10 raised to the minus 10, but that for a different time. And finally, we have the burn transaction. So the issuer of the NFT can also burn the NFT as long as the NFT sits in their wallet. And the transaction is very simple. It's under assets space burn. And the transaction has a from ID, or the sender of the message, and the asset ID that one has to set. So this is a quick of how, after importing all the required modules, one can define their own NFT, issue it, mutate it, and burn it. So to follow up on the same steps through our UI, let's start utilizing this particular low-code web app that's hosted at demo.internft.org. So to sign up, like just quickly running through, create your mnemonic, set your password. You'd get a mnemonic. If you don't want to save it, just download the private key, encrypted private key JSON, and you'll be logged in after signing up. The first step one would have to follow, like we did in the CLI based transaction issue NFT method that we just saw. The first step would be to create your own identity. Sorry, my Zoom is interfering with my clicking. Yeah, so like we created the number identity in this scenario also, I'm gonna pick up a random a string a username for my identity. So in this scenario, let's pick HackAtom RU as my identity. So the transaction has came as empty. It implies I don't have any coins to send this transaction. So I'm going to quickly do a faucet transaction. The faucet transaction should have sent me some tokens. So let's try it again. HackAtom RU. Yep. So I've got a transaction hash that implies that I would have got my NFT issues. So this is by identity. So if you look inside, there is a set of provision address list, which in this case is the address that I just created, and it carries a username like which is HackAtom RU. If I wanted to define more complex formats of NFT, I could do so and become the issuer of these identities myself. But let's not do that. If I wanted to add more keys to my identity, I can do so by provisioning more keys like so. So let's send the transaction. And yeah, so I can now send transactions from this key as well, and it would be counted as a transaction from this wallet, this identity itself. Now that I have an identity, let's go on to define an asset. So I go to define asset, issue identity becomes my identity. So there are a bunch of mutables and immutable properties that have been predefined in this demo. But by default, you do not have to conform to any of these the properties. You can define your own set. So in this case, a style has been predefined, so it gives a style of red, blue, green. It could be more complex style, it's like a coin or a stamp or a collectible, etc. That would render the NFT representation in the UI as something else. In this scenario, the red, blue, green is just going to add a strip on top of the NFT representation that is either red, blue, or green. The other immutable here is a type, which is either this classification that we're trying to define as an asset, an identity, or an order. So we're going to pick identity. Is it going to have a URI? Let's say it will have a URI. It's going to be mutable. What will be the classifier? So let's say what kind of NFT it is. So let's say it's a HackAtom NFT. Identify, we're going to leave empty. Description, we're going to leave empty. One can add more mutables and immutables also. So like let's say we're going to add a height, and let's set it to creation time, or let's set it to creation time. Set the value as like empty, default value as nothing. So let's submit this and see if we had the classification created. So under maintainers, now I've become, my identity has become a maintainer for this particular classification of NFTs. So I can start issuing these NFTs and mutating these NFTs now, this classification of NFTs. Also, if I wanted to, I can assign some of the responsibilities to manage these NFTs to someone else. So I give an identity here of the person that I want to deputize my responsibilities of maintenance of this NFTs, and I can add ACLs like can they add more maintainers to the set of this NFT? Can they mutate other maintainers? Can they remove maintainers? Also, these are the properties that this NFT has. So if you remember, I created a creation time. So I can to the new assignee of or the delegatee of the responsibilities, I can pick what mutable properties they are allowed to mutate. So that's how I delegate some of the responsibilities of maintenance of a classification, or let's say shop of NFTs. So now that I've become an issuer of this kind of NFT, which is the HackAtom NFT, I'm gonna be, let's say, minting one NFT. So let's go and mint a new NFT. So the classification ID for this NFT is gonna be the classification ID that we just created. So let's just give it that. And I would get a form where I could like fill up all the properties, transaction details that I've got to fill. So the burn height is where I'm allowed to start burning this NFT. So let's say we put it at height 100. The lock height is till what height this NFT is not transferable. So I'm going to put it as -1 so that it's immediately transferable. The URI is the URI of like let's say a linked resource, which is an image. So I'm going to pick one. The creation time is the property that the custom property I linked with this NFT. Let's say it's a block height 1. Let's put it as block height 1. A classifier we put as HackAtom, so that has come as is. The identifier, I'm going to put it as Bitcoin A, let's say, and make it a meta. Description, I'm going to say Bitcoin A again. Mutable style trait, I'm going to pick as blue, and the type is going to be an asset. So, yeah. Now that all the properties have been set, let's issue this NFT to this guy here. Okay. Yep. So there's my NFT right there. So let's go and look at how, like, what are the properties of this NFT. So the asset ID, the NFT ID is this. This is the DID. The owner ID is my identity ID. The identifier we set as Bitcoin A. We put the classifier as HackAtom. Description as Bitcoin A again. Type as asset. Burn height is 100. Lock height is -1. So there's no lock on this NFT. Creation time we put ourselves. So all of these properties I put as meta properties. So all of them are available. These data types are available in. They are exposing the .string methods. But if I made them meta properties, non-meta properties, then they would all be just showing up as hashes and not exposed properties. So let's try selling this NFT at this point now. Yeah, I think we can skip the sell functionality considering the time limitation that we might have here. But anyways, if I were to create a sell, I would have to go to orders and define my own marketplace order type, and put the classification here, and then I would be able to place a sell order. My orders will show up here, and all the open orders will show up here. So these are all the NFTs that are available for anyone to buy at this point. So you could create your own classification of NFTs. You can then like sell them on this testnet marketplace if you wanted to, and yep, that's the no-code way of defining your own NFT and like putting them on a marketplace. Nadia, how much time can I extend this further for, or is my time up?
I think it's like 1 hour past, but I think we have like 20 minutes more, as long as we don't have many questions, so we can just continue a little bit.
Oh, okay. Yes, I got a lot of ground to cover. So yeah, I think we can easily take up the 20 minutes. Okay. So in this section, we are going to define how to build your own module, own asset module. So let's quickly look at how to make your own like asset module. Yes. Like this is the persistent SDK, GitHub, the project that you can download from the GitHub is the persistent SDK. These are all the modules that we were just mentioning. The assets module, the classifications module, the identities module, the maintainers module, metas module, the orders module, and splits module. So all of these modules are defined here. The interfaces or the types of the structures used in these modules are defined under the schema package. So let's look at the interNFT interface that would be present in the mappable, since it's being mapped to a KB store. So this is how the interNFT interface is looking like right now. It right now is extending the NFT module, the NFT interface, which is the simplest format of interface that one can utilize if they do not want to implement any special functionalities like vulnerability, lockability, splittability of the NFT. It extends the document module, which is a basic like DID document interface. So this implies that this interNFT metadata conforms to the DID document representation. And on top, it has other properties like burnable, lockable, splittable. Burnable allows this NFT to be burned after being minted. Lockable allows this to be locked to a wallet till a certain height. And splittable allows the numeration or the number of the tokens created from this NFT to change. So, for example, one can have NFT representing a piece of land, and one can create 100 shares from it and distribute it to the part owners or the partial owners of this piece of NFT internally. The kind, or like creating an NFT for an organization like Google and having its share represented as 100 tokens and sending them across to the part owners of this NFT, which is the company Google at this point. So this interNFT interface is implemented at the assets module. So what has one got to implement to recreate a module of their own? So one has to create a new module object. The new module object will take parameters like the module name. Auxiliaries are the exported methods, the exported keeper methods that this module exports. Everything else is internal. Any helper methods that this module exposes are put in the auxiliaries package. So what are the auxiliaries? The genesis, what will the genesis look like? So if, what would be the state of this NFT at Genesis? So like in this case, there will be no mappables inside and the parameters will be this. So one has to create a Genesis object. Then mapper object. A mapper object is just mentions what will be the prototype for the key and the prototype for the mappable. The key is defined in the key package, which is the identifier. So in this case, it's the asset ID, and one has got to define. And the mappable is the object that is linked to the key. So in this case, it's the interNFT structure. So the mapper just has got to take the key and the mappable, and it can create a mapper for this module. Then we have got the parameters prototype, as in all the common parameters that could be changed through governance that this particular module has. So, for example, in this case, they have a demi parameter, which is having a value of smallest text. So, one has got to create a parameter and then define the parameter set and pass the prototype to the module. The queries will be the set of queries that the GET requests that this particular module REST server will respond to. So in this scenario, there's a query called asset, which on being supplied DID will return back asset. So one has got to define all the queries and supply the prototype of the queries to the module. Then the simulator contains all the methods that create randomized genesis state, randomized parameters, randomized mappables and keys. And these methods help the sim app to run a simulation on your module. The transactions prototype define all the transactions that your module will implement. So, for example, in this case, there's a burn, define, deputize, mint, remunerate, and revoke transaction. The transaction needs to have a keeper, a message, a request, a response, and a transaction prototype object. Very similar to how Cosmos SDK does it. And last, we have the block prototype. So the block object defines the begin and end blocker methods, the begin and end blocker method. So this particular object prototype tells how the what methods or what functions have to be called at the beginning and at the end of each block on behalf of this particular uh, module. So yeah, that's a very high level of how to quickly recreate your own assets module, and which will implement the interface inter NFT. So the major changes one will have to do is basically in the implementation of how you would what would be the structure that you'd want to follow for your NFT. So this structure would be the main area of focus, I believe. And other than that, I guess the transactions will be the other area of focus where the majority bulk of the mutation to this module may come from. So yeah, that's a very high level of the structure of the module itself and how to create one on your own. The brief steps have been defined here. Define your directory structure, your mappable, your ID, your collection, etc. So I'm now moving on. Yep. Let's get into the bird's eye architecture of how these modules are interacting with each other. Uh, so the assets module implement the NFT, inter-NFT implement the inter-NFT interface. The inter-NFT interface adheres to the ID spec, which is defined under the GitHub of the inter-NFT GitHub by RFC 00, NFT RFC 006. So this particular RFC defines the specification of how the NFT should behave like. And the IID spec is an extension of the DID core spec. The DID core spec is defined by, it's a specification defined by W3C, is a W3C standard that defines how one can create a DID, decentralized identifier, and implement authentication verification methods on top of it. So this NFT, inter-NFT is adheres to the IID spec, which is a member of the family of the ID specs. Each NFT is identified by an ID, which is resolvable through the query that we just saw, the assets query. I'm sorry for the disturbance. The NFT, the asset structure represents the document, ID document. The ID document is stored in the KB store of the assets module. The controller, going by the DID spec nomenclature, each DID has got a controller property which has the rights to change or mutate or deactivate a document. So the controller in this case would be the classification. The classification in turn will have a controller which will be the issuer identity. So each NFT is controlled by a classification, and classification is controlled by the issuer identity. The classification that we have defined may inherit their properties from other classes that we can define, and one can compose these classes in n layers of inheritance, as long as the total number of properties stay below 22, which is a parameter that has been set in the NFT in the metadata module. On inheritance, if there is a controller property set, then that controller property is inherited down to the child classification also. So what that implies is one can define an NFT template which is open, which is not owned by any issuer or any controller, but it is a generic template. For example, one can define a car template that is owned by no one. So anyone, but as soon as I define a controller, property on it, then, for example, let's say a Toyota car, which inherits from the car classification, then the Toyota car will start having a controller, which will be the identity, which will be belonging to the root authority of Toyota, and only Toyota can then start minting these. And even if Toyota were to inherit the Toyota car classification into, let's say, Toyota Prius classification, then the controller of the Toyota Prius classification will still be Toyota. So that's how like inheritance has been implemented in interNFT. Each IID document, as with the ID documents, they enlist a list of verification methods. So in this scenario, they are either SHA-256 hash method, or it's the SPEC 256 signature verification method that one can utilize. So there will be a public key specified, and anyone who signs a transaction with that public key will become the can execute the verification methods on this NFT. Alternative to the verification method, also the root identity or the controller of these NFTs can issue a signed object to any other identity that can utilize this object, which we call as a ZCAP object or authorization capability object, and submit a mutation transaction with this object, as long as the object is valid and signed by the correct authority, without needing any ACLs. Anyone, the identity holding the ZCAP object can then send transactions to mutate the NFTs or exercise rights on the NFT. And the ZCAP objects are fully off-chain. They don't have to be recorded on-chain. They just have to be verified on-chain. So this solves a lot of privacy issues also around like exposing who controls what NFT and issues what NFT. The verification, yes, so as we just saw in this demo, that each identity has a bunch of verification methods, which in this case are the public keys of. These keys are rotatable. One can provision these keys, and like the verification methods are not bound to the identity. The verification methods are rotatable that way. Whenever a verification method is rotated, any ZCAP objects that is issued by this verification method on behalf of this identity become invalid immediately. So for example, if I were to create a ZCAP object with this key from this identity, and if I were to unprovision this key, then all the ZCAP objects that were issued through this identity on this key becomes invalid forever in the future, unless this key is initiated into the verification methods. As we discussed in the beginning itself, although the control property and the document is self-controlled, the ownership representation is through a token that sits in the wallet, and that is represented through the splits module, which is present here. The splits module. So the splits module implements a structure which is very similar to the coins module, coin structure, and also exposes transaction to wrap coins into splits also. An NFT token ownership can also can be refunded, so like, or renumerated. So one NFT could be linked to, like, let's say the smallest deck of a split, or they can be linked to 100 million, an amount equating to 100 million too. So that allows for you to have fractional ownership as well as have multiple unequal owners of one NFT. So, but this is very different. The fractional ownership component is very different from the component ownership. So, for example, if there is a piece of land that is fungibly owned by 100 people without defining who owns exactly which uh, longitude, latitude from that land, then that particular way of representation of ownership would be fractional ownership representation. But what if I were to divide that land into 100 pieces of land, each specifying the coordinates of the starting and ending boundaries of that land? So in that scenarios, each of the component becomes NFTs in itself. So that this format of NFT also allows you to derive more NFTs from a piece of NFT. So in that scenario, the derived NFTs, the controller become the original NFT, and the original NFT ownership is controlled through the tokens. And the NFT tokens or the NFT ownership representation can also through IBC be shifted over or transferred over through to other chains. So this is a quick uh, sequence diagram representing the transaction flow for one NFT. It is very similar to like what we had just demoed through the transactions and through the web application. So I'm going to skip this and directly go into the modules, discussions of the modules themselves. So the document module is actually the assets module. It has been renamed in this particular. It's supposed to be refactored soon into the next iteration. So document basically module basically represents the DID document linked to an NFT. So it just stores a basic set of properties, which is the classification ID, which sets a template for what properties may belong to this document, and on a set of properties, which may be mutable, immutable, meta or non-meta. It exposes transaction to mutate one document, to delete or deactivate one document, or create one document. So it's a very simple CRUD document creation, reading and update and deletion module. Then we have the classes module, or in the current implementation referred to as the classification module. The classes module define a set of mutable and immutable properties that are linked to each NFT and are able to generate a classification ID from it. So any NFT that carries a classification ID will have to conform to the properties defined under the template or the classification ID. This particular module exposes services to conform to a NFT classification, which implies that if I supply a classification ID and a set of mutable properties, this particular method will return true only if the immutable properties defined in the classification matches the mutable properties that I have supplied. Then we have defined transaction. Defined transaction helps create a new classification like we did in our demo. And that's it with the classification module. As for the identities module, create a DID document that is linked to a bunch of verification methods, which in this case are the public keys, and can be utilized as a terminal or end controller document that represents a actor, which may be a human or which may be actor that exists outside of the chain. So this basically is a module one can utilize to create identities for other actors. So we have like the transaction that we have here are issue identity, or create an identity, update and deactivate identity. The asset modules is a word that contains logic for the minting, mutation, and the burn of NFTs, with the messages structure being like so, and events being the mint, mutate, burn, remunerate events. The token modules is which in the current implementation is named as the split modules, is the module that maintains the amount worth against ID of against an ID. So, for example, let's say NFT is identified by a DID called A, then the splits module will create a wallet for each identity, which will have a mapping of uh, uh, what NFT ID, which is A, and how much amount is being owned by that particular identity, which in general will be the smallest stake if it's a non-remunerated NFT. So token modules enable transactions to mint, burn, and remunerate, transfer, wrap, unwrap. So mint is a service that helps create new splits if a new NFT is created in lieu of that new NFT. Burn uh, destroys the splits created. Remunerate increases or decreases the total supply of the splits that are already present. Transfer is like the send transaction, which sends the ownership of the splits to another wallet. Wrap and unwrap convert the coins structure into the split structure and back. So, for example, the one can take an atom and convert it into a split and have them linked to an identity rather than the public key account. So the event it remits is the send, wrap, unwrap, and the parameters that it exposes is send enabled, wrap enabled, or unwrap enabled. So these are all the modules and the transactions that they expose. So now we can quickly discuss the interfaces that these modules implement. So we've got the basic ID interface, which return back a string that conforms to the DID specification. We have got the simple NFT interface, which defines the simplest structure of NFTs, which do not necessarily conform to the IID specification or the inter NFT specification. We have got a more complex interface, which is the inter NFT interface, which extends the NFT interface and has a bunch of new traits like has mutables, has immutables, burnable, lockable, splittable. Um, base implementation of the inter-NFT interface would look like this. It will have an IID, it will have a bunch of mutables, and it will have a bunch of immutables. So has mutable trait will expose a method called get mutables, which will give me all the mutables. Has immutables will give me mutables. Burnable will give me a property which will be the lock height. Lockable interface will expose a method called get lock, which will give me back lock height. Splittable will give me a value, a property, which get value method, which will give me a value property, which will tell me how many, what is the amount or what is the number of splits that one NFT has. So it could be the smallest deck, like by default for each NFT, or it could be increased if the NFT is allowed to have splittable ownership or fractional ownership. The fact interface is what stores the property values. These also carry the signatures, which could be utilized for recording verifiable claims on these facts. So, for example, your NFT could carry another property. Let's say your university degree, a bachelor's degree, and this property could be signed by the university and can be utilized to verify the claim that you graduated from the university that you specify in the NFT. We have the property interface, which is basically a key value pair of ID or identifier of a property. For example, the name, color, etc., or any property linked resource to the NFT, and fact being the value. The fact by default does not actually contain the data; it just contains the hash of the data. the actual data is contained by a metadata object, which has which is represented by the data interface. Currently, there are 4 data types that are supported. There is text data, height data, ID data, and string data. Uh, uh, and these metadata are maintained by the metas module. The classification objects are represented through a classification interface, which exposes whether get mutables. And yep, that's all the like interfaces that are utilized to implement the NFT modules. So yes, I mean, I think that's all of it. I think I've covered a lot of area right now, and I know it would be a little confusing, but we have very well documented all of this text at the interNFT.org GitHub repository. So all of these RFCs, all of the ways of implementation have been recorded here. So I think this one would find this useful. And on top, like this particular notes also have been shared. The link for this also has been shared. So one can refer to this particular document also while trying to implement module or an NFT application using interNFT modules. So, yeah, thank you for joining in. Over to you, Nadia.
Thank you, Deepanshu, for such amazing workshop. Yeah, this is so informative. I think everyone will be happy to know all this info. So all these links that you mentioned before, please send me to Telegram group or somewhere else. So I will share it. Yeah, perfect. I will share it with our participants. So I'm checking now, do we have questions or not? During the workshop, there was no question. There was a few discussion around the topic in our chat. So yeah, we don't have question in Russian channel. Yeah, in Cosmos channel, everybody say thank you for such an amazing workshop. And yeah, so we can finish. Actually, we can continue. Please, guys, join our hackathon. We have amazing prizes. We have amazing speakers and mentors. And see you on the next workshop tomorrow. Bye.
Thank you.
Thank you. Thank you. So.